Hello friends, in my previous video I have explained open loop system and closed loop system. If you did not see the video, you can see that going to my profile, and today I am going to discuss about the feedbacks of control system. So let's start. There are actually two types of feedbacks. One is positive feedback and another one is negative feedback. Now, what are these feedbacks? We can understand it with a simple block diagram, and in my previous video I have explained the different block diagrams of control systems. So now, if we take any system where the system transfer function is GS and the input is RS and output is CS, then we can call it a open loop transfer function, and that will be GS. Means in this case the open loop transfer function CS means output by input will be GS, and this will be the open loop transfer function. Now, if we take a closed loop system where the input is RS, the system transfer function is GS, it is actually the Laplace transform. We take the Laplace transform everywhere because we need to calculate the transfer function when all the initial conditions are 0. Here the output is CS, but there is a feedback path HS, and the feedback can be positive or negative. When the feedback is negative, means minus HS, then the overall transfer function of the system will be like, I am writing this, GS by 1 plus GS HS. Very easy to understand. And if it is positive, if the feedback is positive, then overall transfer function, remember overall transfer function, this is overall transfer function, and only GS, that is actually system transfer function, right? The plant, right? This is the plant. The overall transfer function in case of positive feedback, will be like GS by 1 minus GS HS. This is just a simple example and a representation. By this you can calculate the feedback and the transfer function of any system by this mathematical equation. Now, some important point about negative feedback and positive feedback, I am going to talk about those things now. The first point, the very important note. You better take a copy and write these points in your copy, and it will help you later, I am sure. Take the note. The first note is no feedback guarantees stability. See, our motive is to bring the stability to our system, and we will talk about stability later in various cases. The actual target is to gain stability, but no feedback actually provides or guarantees stability, or instability also. But in case of positive feedback and negative feedback, we have to remember the points like negative feedback guarantees more stability than positive feedback. But negative feedback guarantees more stability than positive feedback. Point 2, this is also very important, and that is, in spite of having negative feedback, control system can still become unstable due to high open loop gain, high transportation delay, and high sensitivity. You can remember these points. This will help to get good marks in exams and also in the basic understanding of feedback. So take the point. In spite of having negative feedback, control system can still become unstable, though it provides more stability than positive feedback due to high open loop gain, high temperature delay, and high sensitivity. These are very important point. Note these down, it will help you. Now, the last important discussion about negative feedback and positive feedback, I am going to show the difference between negative feedback and positive feedback in case of obviously closed loop system, in case of closed loop control system, and this chart will help you to remember all the points regarding negative feedback and positive feedback. I'm writing it here. I am taking a criterion column, and this will help you to remember this topic in a very easy way. I am taking negative feedback here. I am taking positive feedback here. So the first criteria will be gain of the overall system. In case of negative feedback, the overall gain will decrease. And in case of positive feedback, the overall gain will increase. Bandwidth. In case of negative feedback, bandwidth will increase. And in case of positive feedback, bandwidth will decrease. Third point, very important point, time constant of the system. In case of negative feedback, time constant will decrease, and in case of positive feedback, time constant will increase. Now, the very important point, I have explained it before, that is stability. Remember this always, stability in case of negative feedback always increases, and in case of positive feedback decreases. Fifth point, that is our speed. Obviously, in case of negative feedback, speed increases, and in case of positive feedback decreases. Sixth point and the last point, that is about sensitivity. Sensitivity in case of negative feedback, sensitivity decreases, and in case of positive feedback, sensitivity increases. Now, there are two very important points. One is stability, and second is time constant of the system. Now, if you remember the stability, you can easily remember the point speed of the system. Now, gain you can understand looking at the transfer function expression which will be given in the question. Now, the topic sensitivity I will discuss, which is unknown to many students, and many students ask about this question that, sir, what is sensitivity, and I am going to explain that now.